So in this tutorial, what we're going to do is we are going to look at the importance of ortho mode, and also how to draw in Rhino, and particularly to document in Rhino in a precise and rigorous way. This is especially important when we're using, as we are here, some sort of reference image that is not in vector format. This is a rasterized drawing. So, when we zoom into this, we have the fuzzy kind of raster quality to this, meaning if I was to, say, use this as a reference image for getting a floor plan down, and I was to just trace over things, there'd be a lot of inconsistency, like this. If I was to just go around and just kind of draw these lines, and for the moment here, because we're going to talk about the importance, pretend ortho mode is off, and I was to just kind of draw this and come across and do this in a relatively fast way, you can even see here, I'm going pretty quick, but this is obviously not 90. This length, a lot of the angles are off. There is kind of inconsistency across the length. Here, this is 9:8. This is 9:21, 30 seconds. And those are all, issues that I was not intending. It's kind of sloppy, and it will yield a lot of other problems for you down the line, because these are the kind of baseline for everything we do. They're the scaffolding. It's really important that these are very precise and kind of thought out. And so I'm going to kind of show some tricks to how we would draw this in a more precise way. The absolute most critical idea in Rhino, I think, is really well captured by this concept of ortho mode. So zooming back even further here, Rhino works on a coordinate system. So there is a y-axis and there is an x-axis if we're in 2D, as we are now in this top view, but we can, hold Control and Shift and right click, and, of course, Rhino also works in 3D, and you notice down here on the world grid, the z-axis pops up, which is this x is exactly 90 degrees and perpendicular to the y. Either of these horizontal planar axes are 90 degrees and exactly perpendicular to the z-axis. We can see that if I go back into that top view, by my hotkey is TT, we can see that in this grid, that is one of the kind of base settings that you can either toggle on or toggle off in Rhino. The center of this grid, as it appears, always appears in Rhino, what is called the origin point. So it is the coordinate point of 0, 0, 0 on this axis. And a nice trick, too, is that is a point that you can move to. So if I have this over here, and I want to move this geometry to the center of this grid, or just to the kind of the conceptual center of the Rhino model, I can do that by just typing move and then 0, enter. And that's going to move me exactly to the center here. Personally, I tend to turn this grid off, because that's, I understand this concept and I find it a little visually distracting when I'm working with my line work. If you're struggling with this concept, I would encourage you to leave this on as a reminder. But if you're, want at any point to turn this off, the way you do that is you type grid, not grid spelled correctly, grid, and then here it's H, so show grid. You can also just click it, but it turns it off. I'll leave it on for now, just so communicate this. But okay, so we understand that in Rhino there is this grid. there are these axes. What ortho does is it pins the line work to those axes. So you'll notice here I've done my polyline command. I am only able to kind of send this line off to eventually draw one of these lines exactly aligned with the Rhino grid. I would say for myself and also for you guys in architecture school, 99.9% of everything you do should be in ortho mode or at least rationalized along this grid. There are exceptions to that. So say, here you can see this is I've chosen a pretty kind of rectilinear project, but there's still curves. There's curves in the in the arcs of these door swings. There's curves here. There's a kind of curve here. But you'll see when we go about creating these, we're not just kind of in here. I'm going to turn ortho mode just to illuminate a point. We're not creating these by kind of just randomly trying to align with this. The way one would create this is in a precise way, we would try to find the base of this. We would come across, like this is just going to be, this is less precise than I'm going to show you guys how to do in a moment, but we would create an arc and we would come across, it's not exactly, obviously this is not parallel to the parallel or perpendicular to either of these grids, but the underlying geometry, the way that we created it is. So this is a parallel line and we brought an arc over that. Similarly with this, with the door swings, we would kind of bring an arc across this doorway and bring that to 90 degrees. Okay. There are moments where maybe it's not helpful to we need to kind of get outside of what is allowed in here. I would say there's two ways that you can do that. One of them is, say we want to trace this furniture and we're like, oh, this is not exactly, obviously we can't do this just with squares. If ortho is toggled on and you hold shift, you can temporarily turn it off and trace whatever object you want. I will warn you that this really, tracing furniture or scale figures is really the only time that I am regularly doing this. Maybe you have to trace some landscape feature or something else, but when it comes to the actual architecture, the walls, the general layout, you want to be modeling that in a more rigorous way. And what do I mean by rigorous? Here's what I mean by rigorous. So first off, how did I get this scaled to where it is? There's no drawing scale. Most of the examples that you guys have for this project, maybe there's a scale. If there is, use that. And so I'm going to turn this off for a moment. And I'm going to hide this. Hide this. If there is a scale, select your image that you've brought in and do the scale command and, go from one end of the scale bar to the other and type in, maybe it's 10 feet, whatever it is. And then that will bring your drawing to the correct size. Another thing to think about as you bring in these kind of reference images, I pulled this directly from the architect's website. It is, this is a drawing they created, and so I'm making the assumption that, that this, as is typical, this bottom line of the building is exactly parallel to the edge of the paper. I could perform a check on that. I'll toggle off, how do we want to check that? Here's what I'll do. I will toggle off ortho by holding shift. I will draw a line as best as I can across here. And then I will type the angle command. And the angle command works similar to distance, where it will tell you the angle between multiple objects, but it will not kind of pop that up as a text item. So let's just go, I want the center, I want the difference between this angle and this angle, 89.889. Obviously that's not 90 exactly, but this is not a vector drawing. To me, that is close enough for how imprecise it is for me to try to, align get these lines exactly centered on a fuzzy line. So for me, that's enough to be like, okay, yeah, this is angled. If say you're working from a scan, that maybe when you bring your drawing in, it looks like this, like with the paper kind of being the paper looking, horizontal, like the face of or the edge of the paper not aligning with the edge of the building clearly. Then the first step you'll have to do is to rotate this to the best of your ability to be 90. Oh, wait, rotate. So you would do that. Say if it was like a scan, if it was some poorly, if it wasn't kind of a digital raster file, if it was a raster file created from a scan of a physical piece of paper with maybe a fold in the middle, I'm going to just undo that so that we're back to, yeah, okay. So if that's the case, come talk to me, and we can ensure that it's pretty close. But still, while I might not be having to make angular guesses here, like I know that like lines that are shown as 90 here are probably 90 in reality. I am gonna I am gonna have to make judgment on and kind of be treat different building features somewhat in a similar way. That will make sense in a moment, but just finally, assuming we don't have a scale here, which we don't for the project, the way that I ended up here, which may be similar to how some of you guys are having to work, you might just know, maybe you've read some text about your project, you have a plan or you have a photograph, you have something, and you hear that, you read somewhere that the exterior wall is 1 foot thick. It's like you can take your whole drawing, or the overall exterior of the building is 120 feet or something. You can scale that known distance similar to how you would use a scale. It's not quite as exact, but as a starting point, that will work. The way I got to this one is based on my knowledge of the project. This is less exact than I would kind of hope that you guys are working with, but just for clarity and whatever, I'm just going to do this example. It's a framed building in a climate where I expect the walls to be about 10 inches thick overall, and often on residential projects, 3 feet is a somewhat typical width for exterior doors. So that is what I set this to. This is, I thought I had this at 10 feet. Or 10 inches. Yes, and so that's actually a great example of what I'm kind of talking about here, is that when I first snapped the dimension here, it said like 9 something. When I did it here, it was 10, 19, 30 seconds. So when I draw this out, this wall should not be at 9 inches something and this wall at 10, 30 seconds. These walls should be the same. And the fact that they're not the same, if we were to trace over this, is not a result of like what the reality of the project is. It's a result of the imprecision of working with raster drawings. So what we're going to do instead, so rather than kind of trying to trace everything out, we're just going to draw a big line across here as a placeholder. And we're going to draw a line down here. And then I'm going to okay, we thought this was about, I thought this was about 10 inches. Let's just double check at this point, say 9/7/8. That's close enough for 10 inches for me. So I'm going to lock this picture layer. I'm going to also, that is a good moment to say, I throughout all this, I'm going to be working with the aliases, and in the template save as file that I show in another video, if your layers do not look approximately like this with print widths and everything set up, and you don't have aliases set to the typical commands, like, finish this video or even stop this video and just do that, because it's going to be a lot easier. Certainly do that for this first project, and I really encourage you guys to check that out. It saves an enormous amount of time. So I'm offsetting this by I'm going to offset this. My command is fs by a distance, and that distance is 10 inches. Boom. I'm going to do the same here, even though when I did that initial trace, they were not quite the same. But in this project, they should be the same. The only reason they're not the same is because we can't, zoom in enough or find the exact center. So you'll notice, yeah, this kind of comes all the way across cleanly. Great. So, okay, how about the overall width of this project? To start out, I'm just gonna do the distance command, and I'm gonna try to get close. Let's see what this is. 23 1-inch. I'm gonna actually do that again. It's 23. Okay, so 23. I'm taking it at a similar place, but I just wanna, for simplicity's sake, on this project, I'm just going to do this at 23 feet. Or feet, not inches. You can see it's still kind of within the line, but I'm just trying to remove funkiness, right? You can kind of, some of these are judgment calls. This is kind of gray area territory, but I'm going to offset this 10 inches. But for the purposes here, for the purposes of displaying this drawing on 11/17 sheet of paper, that difference is not going to be distinguishable. And it means that, when I'm describing my project, I'm going to be able to describe it in much cleaner terms. So some of this is kind of, some of what we're doing is we're making these kind of assumptions for clarity. Down the line, some of these assumptions may be more specifically informed, like on, if I was really kind of getting into things, I knew this was a framed wall, perhaps, or if there was, if I'm trying to decide where some interior decision is, where a division is happening, maybe I'm choosing it based on a number that closely fits with typical stud spacing in framed walls. If this is a block project, maybe it makes sense that the edge of something would time out with a block setup. But for the purposes here in this kind of early, I'm just trying to not have this end in a crazy fractional number. I'm gonna do the same kind of exercise of measuring and then finding a kind of cleaner number across for these interior divisions. So this first one we did, this is 12/8 and 5/16. My assumption here is that this just from looking at this project, I'm guessing that this is pretty similar to this, possibly the same. So I'm just going to take a couple dimensions from each of them and then choose a distance that we're just going to call each of these rooms. So this is 12/9 This is 12/8 and 3/16. It seems like they're all pretty close to 12/8. So I'm going to have that as my baseline for each of these, meaning when I offset this, I'm going to offset that by a distance of 12 foot 8 inches. Boom. How about the depth of this interior wall? Clearly there's this thicker wall that we're calling 10 inches, but it seems like there's also this thinner interior wall that happens at certain points in the project. Let's just do a basic measurement of this. 5 and 5/32. This one is 4. I think for simplicity and also kind of thinking down the line to making a model of this thing, what I'm going to do is I'm going to choose 5 inches. The reason for that is a couple of reasons. One of them is 5 inches is a somewhat common interior buildup when you take into account 2x4 studs. And so it is a dimension that does kind of like exist as a typical wall assembly in the real world. But even if you don't kind of know that offhand, which I'm not expecting you to, it's just rational. It makes sense with what we have as our exterior. For our exterior, we have 10 inches. For our interior, let's call it half of that. And what this will allow us to do is down the line, thinking about making a physical model of this thing, a lot of sheet materials, so like chipboard, all that kind of stuff, are sold in increments that double. So it's like 1/8 inch chipboard, 16th inch chipboard. And so thinking down the line, having one wall on the inside be exactly half of the exterior wall will make fabrication of our model a lot easier. So that's why I'm kind of choosing, why I kind of landed on that 5 inch increment. So then here I'm going to do just a couple more here, but what did we say? This was 12 foot 8 inches. So 12 foot 8 inches. And then for this one, this is not the thin wall. This is that thicker exterior wall. So this one in our drawing is 10 inches. So just like important to note here, I'm sure it's not lost on you, but the way that I'm kind of building this out is not from, going through and tracing everything. It's like you do the distance to find approximately what something is, and then it's much more kind of precise movements or offsets to align things where you want, and you're working with kind of a set of rules that you've created for yourself. I'm going to also just measure this exterior one approximately so I can get that in 129, let's just call it 129 8 inches. Offset 129 8 inches. Wait, that does not look right to me. I think it was maybe to the interior. 129.8. Oh, weird. Let me try this again. Offset 129 feet 8 inches. There we go. I don't know why that was looking weird for me. Okay, boom. And then we're going to offset this inwards by 10 inches. Great. I'm going to hide this for a moment just so you can see. I'm also going to turn off the grid just because you can see why. So H. Okay, so we're going to do one more addition to this, which is this hallway that comes across. I'm going to measure down. This is that same exercise of kind of getting an approximate distance. 4.9 runs across all of these. 4, 10, 4, 9. Taking it from a few different spots, which ultimately doesn't really matter because these are all parallel, but I just want to, let's just call it 4, 9, how about? So I'm going to just take this because I know there is this big hallway that runs all the way across the thing. So I'm going to offset 4 foot 9 inches. Boom. Great. That's bing, 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 bing. You can see it kind of aligning all the way down here. I'm going to offset this. I think we had set this at 3 feet, but yeah, let's call this 3 feet. 3 feet. Boom. Okay. So we have this. I'm going to also just kind of move this so it's kind of hanging out on either side. And so now, you know, if we remember, this big one on the outside is the exterior. This is kind of this hallway that tracks across. And so the exercise here, like the drawing you're doing, is not actually like drawing lines separately where you have to zoom in and line it up. It's kind of, you get the logic down, and then it's actually a lot of trimming. So this is that exterior. We're going to trim that out. I'm actually going to even just select all of this so I can do multiples at once. I'm going to trim that. I'm going to trim this, 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 this. Boom, boom. I think that we'll have to refer to the photo, but I'm going to select all of this. Trim, 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 trim. Boom. Okay, I'm actually going to pull this a little more centered so it oversides. So, great. There's this kind of, I mean, there's the beginning of it, but there are some of these important relationships. I'll also select all of these and use the split command. ST is my hotkey. And I'll split all of these, and I'll turn this into, I don't have an above line now, so I'll just put this on a light line for now. So delete that. And then I will get rid of all of this. So, great. This, yes, this looks like important, not all of it, it's obviously not done, but this looks like, this aligns with what we're referencing, but what's really important to note is because we used ortho, because we were not just kind of blindly tracing, because we set up kind of order in how we were creating this, this is a very, like if I take some distances from this distance, 23 feet, this distance, 29 and 8 inches. Let's look at every exterior wall. 10 inches, 10 inches, 10 inches, 10 inches. Let's look at some interior, that interior division. 5 inches. You know, there's obviously more interior spaces. If we had had one coming across, that also would have been 5 inches. And even if you were to have really zoomed in and got really close to the center of this line by doing just like a straight up trace the whole thing exercise, yeah, I think if we were zoomed out a lot, you probably couldn't tell the difference. However, you definitely so assume that we want to make other kind of we have to do other things to this. Say we want to put a hatch in. By having this be kind of just precise and rigorous, it means that if you were to put a hatch on this section, you could just rotate that down and you would know that it would exactly fill the wall on this side. If it was, you know, not 90 degrees and you put a black hatch, there'd probably be a little white sliver open and you would have to separately drag that to the corner. It would be a lot more time consuming. When you go to do dimensions on this, you know, you can just put we're gonna drag this up and it's, oh, because this is decimal, but but this, if we go to fractional, properties, length units, fractional inches, fractional, or feet and inches even. Boom. You know, not like 12 foot 8 and 15, 30 seconds or some strange amount. This is how we need to be modeling. Where the where ortho is always on, unless there's a really good reason for it not to be on, and it's not even really architectural that you're doing. And secondly, that it's not just a blind tracing exercise. Like, by doing it this way, I kind of know more about the project. This is close. This is really close, and honestly, with this rasterization, it is well within that black line. So it just tells me more about the project. I'm like, oh, I understand this exterior. The exterior walls have to do this. The interior walls have to do this. The doorways, maybe we look at this and we're like, oh, this is 5 inches, and what is this? This is 6 inches in between. Let's call it 6 inches. And so then you can, rather than just kind of tracing this where you're like, a line goes in this way, by drawing something in the way that I'm describing, it forces you to understand more about the building. So here, I'm not just like, oh, the line in this project goes across here because I'm tracing it. I now have the knowledge, oh, like on this project, like the line, the kind of a wall is offset 6 inches from a door. Is that universal across this project? Let's see. Yeah, that basically is always the case. So that's this kind of like useful touch point for your own design. Similarly, like, oh, here's this kind of sitting, what is this? This is kind of a library room. Oh, what is the dimensions of this room? Oh, 8 by 12, 8. Rather than just thoughtlessly, here are the lines. Yeah. Hope that was helpful. And let me know if you guys have any questions. Okay.